This question is given in GATE 2008. Consider the following circuit using an ideal op-amp. The IV characteristics of the diode described by the relation I equal to I naught into e power V by Vt minus 1, where Vt equal to 25 millivolt, I naught equal to 1 microampere, and V is the voltage across the diode. It is taken the positive value for forward bias. Now, for the input voltage Va equal to minus 1 volts, the output voltage V0 is given by, they are given 4 options: 0 volt, 0.1 volt, 0.7 volt, 1.1 volt. This is the diagram given. If you know the concept, you can solve this question very easily. Okay. Now, if you observe this diagram, this is the op amp given. This is the op amp. Now we need to calculate the value of V0. Okay. This is the diode D. Now, how we can calculate the output voltage V0 is, V0 can be calculated from this point to ground. Okay, V0 can be calculated from this point to ground. Now they are saying that op amp is ideal. Op amp is ideal one. This is one of the important key point. Okay, op amp is ideal one. We know that whenever op amp is ideal, its open loop voltage gain AV will be equal to infinity, and AV is given by V0 by VID. Okay, now you take VID equal to V0 by AV, that is equals to V0 by infinity. Anything by infinity will be equal to 0. So here we are getting VID is equals to 0. VID is nothing but the difference between two input terminals of an op amp. Okay, VID is nothing but difference between two input terminals, that is plus terminal and V plus and V minus, that is equals to V plus minus V minus is equals to 0, V plus is equals to V minus. So the difference, like the voltages at both the terminals of an op amp will be at same voltage. This concept is called virtual short. This you should remember, virtual short condition, which means here the plus terminal of an op amp is at 0 volts, ground is nothing but 0. So minus the inverting terminal should be also at 0 volts. So the voltage at this point will be 0. Now instead of calculating from this point to this point, if we are able to calculate from this point to this point, it is enough. So such that we can get the value of V0. Now V0 can be given by this equation. V0 is equals to voltage at 4 kilo ohms plus this diode voltage. This diode voltage V is nothing but simply the voltage of diode, and this is equals to here current passing through it into the resistance value. Okay, plus V. If we are able to solve this equation, then we can easily get the V0 value. Now let us assume that I is the current passing through this 4 kilo ohm, and the same current flows through this P side of the diode, which will make this diode forward bias. This diode forward bias, and it will come here. At this point, the entire current I flows through this resistor. It will not go through this inverting terminal, because op amp is ideal. Another important characteristic of op amp is Ri is equals to infinity, which means it will not allow any of the internal current that flows through this op amp. So the all currents through this op amp flowing will be 0. So the same current will flow through 100 kilo ohm resistor. So if we calculate current at 100 kilo ohm, then the same current will be at this 4 kilo ohm and this diode. So current at 100 kilo ohm resistor equal to the voltage difference by this resistance value. Voltage difference, this will be at 0, minus of minus 1 by 100 kilo ohm. This will be equal to 10 microamperes. So current through this 100 kilo ohm equal to 10 microamperes. Now we will calculate this diode voltage. Diode voltage can be calculated by using this equation. ID is equals to I naught into e power v by vt minus 1. Now this drain current they have given as this one 10 kilo ohm. 10 microamps equal to 1 microamp into e power v by vt is given as 25 millivolts. 25 milli minus 1. You can use scientific calculator for calculating this. So by using after all calculations you will get v as 0.06 volts. So substitute this v value in this equation. Okay, substitute this value in this equation, or this equation we will get v0 as v0 is equals to I is nothing but 10 micro into 4 kilo plus 0.06 volts. This will be equal to 0.04 plus 0.06 v0. v0 is nothing but 0.1 volt. This is how we can calculate the output voltage v0. If you observe in the options, option B is the correct answer. How we have derived the solution is, they are saying that op amp is ideal one. If op amp is ideal, then it should be in virtual short condition where the voltages at both the terminals are same. So if plus is at 0 volts, then minus should be also at 0 volts. So v0 can be calculated from this point to the ground, and for that we need to calculate the current passing through the 4 kilo ohm resistor and this diode voltage. So by using this equation we are able to calculate that the current passing through 4 kilo ohm and 100 kilo ohm are same, because as this is at ideal condition, so no internal currents are flowing through this op amp. So we can easily calculate the 100 kilo ohm resistor current as 10 microamperes. Now we have substituted the equation to get the diode voltage. Finally we have substituted this diode voltage and current in this equation to get the output voltage.